before we jump into graphing logarithms, I want to kind of show you where a logarithm comes from. So we've already learned how to find the inverse of an equation. And remember, the first step in finding an inverse is switch x and y, and then you have to solve to get y by itself. Well, if I have an exponential function like what I have here, I can switch x and y to give me x equals 3y, but I don't really have a way to get this y out of the exponent and be by itself. And that's where logs come into play. Logs allow us to rewrite this equation so that y is by itself. And we do that by taking log with a base of 3, because that's the base of the exponent, of x equals y. And it's not important at this point for you to know how to solve this or what to even do with a log, but what you need to know is that exponential graphs and logarithm graphs are inverses of each other. And when we graph logs, we are going to exploit that inverse relationship to help us figure out how to do it, because we don't use our calculators to graph logs. That log button you see on your calculator is really a specific kind of log. It's a log with a base of 10. So let's take a look and explore the relationship between exponential and logarithm graphs. So when we say exponential graphs, the guide points of an exponential, or anchor points of an exponential, are 1, 0, and -1 for the x's. And for the y's, we have b, 1, and 1 over b. Well, because we know that exponential and logarithm functions are inverses of each other, I can find the guide points of a log by simply switching x and y. That's how we find the inverse of a point. So in a log, the guide points, the x values would be b, 1, and 1 over b. And the y's would be 1, 0, and -1. So here's our guide points. B, 1, 1 over b, 1, 0, and -1. Because I know that they are inverses of each other and I have to switch x and y, my horizontal asymptote that was in exponentials becomes a vertical asymptote. The horizontal asymptote for an exponential was y equals k. So when it becomes a vertical asymptote, it becomes x equals h. Domain of an exponential was all real numbers. So when I switch x and y for a log, that means the range becomes all real numbers. The range of exponentials was y is greater than k, or sometimes y is less than k. When I switch that over to logarithms, it's now the domain, and instead of x, or instead of y, it's x is greater than my h value. The relationships of what these transformations do does not change when we go to logarithms. So this is still a vertical stretch. This is still the base used to find the guide points. K still moves up and down. H is still the opposite sign and moves the graph left and right. We're still going to use a table just like we did with exponential graphs. So our first step is to label B, A, H, and K. B would be the 3. A in this case, there's nothing being added or multiplied in front, so that's really a 1, because it just means there's not a stretch or a shrink. Multiplying by 1 doesn't change anything. Then nothing is being added or subtracted with the x, so h is 0. And nothing is being added or subtracted outside of the x, so k is also 0. So this would be an example of a logarithm function where no transformations have happened. So we'll label our guide points. We have b, 1, and 1 over b for our x values, and 1, 0, -1 for y. Multiplying All of our y values by 1 doesn't change anything. There's no transformation happening. Multiplying our h, or adding our h value of 0 to all of our x values changes nothing. There's no translation. Same thing for the k. So the points that I'm going to plot on my graph are all the way back here at the very first step. They're just our guide points. Label our asymptote. Remember that is at x equals our h value, and we'll graph it. So here's our vertical asymptote at x equals 0. And then we'll plot those points. We have one at 1, 2, 3, 1, 1, 0, and 1/3, -1. You can see it's trending down towards the asymptote, which means this line for the graph is going to move along the asymptote, never touching it, never crossing it, and through the points. Make sure you can see that white space in between your line. Our domain would be that x is greater than our h value, because it's to the right of the asymptote, and our range would be that would be all real numbers. For number 2, we need to label b, a, h, and k. B is this 4. A is the number multiplied in front, also 4. And I know that that 6 is really an h because it's found inside the parentheses. All h values for logs will be inside the parentheses, just like h values for exponentials will be inside the exponent. Remember, h is the opposite of what it appears to be. And then k, there isn't one, so we'll say it's 0. List our guide points. B, 1, 1 over b, and 1, 0, and -1. All of my y values will need to be multiplied by a, so all of my x values will remain the same. One times 4, 0 times 4, and -1 times 4. All of my x values will have h added to them, so all of my y values will remain the same, 4, 0, and -4. 4 plus 6, 1 plus 6, and 1/4 plus 6 gives me 25/4. Finally, when I go to add my k, it's 0, so no translation is happening. And it's time to label our h and k. It's time to label our asymptote. Asymptote, remember we write it as an equation, so something equals something. Asymptotes for logarithms, x equals my h value. That's the first thing that we will plot. So I went over 6, and that's where my dashed line will go. And then we'll plot our points. And the last column of points that we apply to transformation to is the point that you plot. So 10, 4, then 7, 0, and 25/4 is approximately 6.25. Well, it's exactly 6.25. And -4. We can see that it's trending towards the asymptote here. So our line will go along the asymptote, being careful not to touch or cross it, and up through our points. Our domain, since it's to the right of the asymptote, x is greater than h, and our range is all real numbers. For our final example, we'll need to label b, a, h, and k. B is 1/10. A is 2. And I know that that 5 is not part of h because It's not found in the parentheses. There is nothing in the parentheses with the x, so h is 0. And then finally k is negative 5. b, 1 and 1 over b. So 1/10, 1, and 1 over b, remember that's the fancy way of saying reciprocal. So 10 over 1. And then y, 1, 0, and negative 1. Multiply all your y values by 2, leaving all of your x values to be the same. So 2 times 1, 2 times 0, and negative 1 times 2. Adding 0 to all of my x values does not change them. So we'll move to the next column where we add negative 5 to all of our y values, leaving all of our x values to be the same. 1/10, 1, and 10. Adding negative 5 to 2 gives me negative 3, negative 5 plus 0, negative 5, and negative 5 plus negative 2 is negative 7. Our asymptote is x is equal to 0. We'll draw our asymptote in. And then we'll plot our points. 1/10 and negative 3, 1 and negative 5, and 10 and negative 7. We can see that it's going to move along the asymptote on the top part of the graph and then down through our points. Our domain, since it's to the right of the asymptote, is x is greater than our h value, and our range is all real numbers.